Hello. Okay, let us try this problem, the circuit problem that we talked about in class yesterday, I think. So I wanted to solve this using Matlab. So I just wanted to show you the entire process how you are going to do this. So again, here in this problem, if you read, this is from the class assignment. So that is week 12, lab 23. So and the problem 2, this is what we kind of discussed in class. So I wanted to take that in the same problem as since you were looking for 6 different currents that you have to find, and you have 7 equations, so 1 2 3 and 4 and then 4, so 7 equations. So which is like you have one more equation than what you need. So I wanted to make it in a way that I wanted to find 5 currents and I need 5 equations. So what I will do, I will take this first 3 equation and then I will skip this where there is I6, and I will skip this equation which is I6. So then I will have this 2 and that 3. So there will total 5 equations, and only 5 will be unknown, which is I1, I2, I3, I4 and I5. So based on that, so if I rewrite the first equation, I would say it would be 0 and minus, say, R2 and then I2. So and then you have no I3, so you would be plus 0, and then you will have I1, I2, I3. Then you will have I4, which is minus R4, I4, and then you have I5, so which is plus 0. So this guy would be equal to your V, so I'm gonna write negative V. So this would be my first equation. So what I also wanted to do is kind of increase the font so it would be easily visible. So this is my first equation. So before I create a matrix, let me write all 5 equations. The second equation, I have a I1 right here. So what I'm going to do, R1 and then I1, R1, I1, and then I have I2, so it would be minus R2, I2, and then I have I3, so it would be plus R3, I3, and I don't have any I4 and I5, so I'm going to write plus 0 for I4 and then plus 0 for I5. And then on the right hand side is 0, so there's nothing there. So that would be my second equation, which is right here. This is my second equation. My third equation right here, I can see I4, I see I3, I see I5, but I don't have any I1 and I2, so it would be 0 and then plus 0, so I1, I2, and then in I3 I have negative, so I'm going to write negative R3, I3, and then I have negative R4, I4, and then I have positive R5, I5. All I'm doing this, just remember, everything I'm doing here is actually you're supposed to be doing by hand. So none of these are should go in Matlab yet. So then equals to 0. That's all 3 equations. So then I'm going to take on this equation and this equation, because I wanted to skip this with I6, I wanted to skip this with I6. So in this equation I have I2, I3 and I4. So I have 0, that means no I1, and then I have I2, so it will be plus simply I2, and then I have plus I3, and then I have I4. I'm going to take I4 in the left side, so I'm going to have minus I4, and then I don't have any I5, so I'm going to write 0, and that equals to on the right hand side 0. So that's my this equation. And then I take the this equation, which is also with I1, I3 and I5. So I will have I1 and there is no I2, then I have minus I3, and then no I have I1 minus I3 minus I5, but no I4, so it will be plus 0, and there will be minus I5. So this I5 and I3, both of them taking the left side, so it will be minus I5, and this guy equals to 0. So I have 5 equations and I know there are 5 unknowns. So from this equation set, let's see if I can create a matrix A. So I'm gonna leave some more space here. So matrix A, in the first equation I have 0 for I1, and then I have minus R2 for I2, and then I have 0 for I3, and then I have minus R4 is the coefficient of I4. Remember that is R4 is the coefficient of I4, and then I have 0 for I5. So these are the first equations. So and then I will have my second equation, which is I1 has R1, so I'm going to write R1, and I have minus R2, and then I have R3, which is coefficient of I3, then no R4, which is 0, and no R5, no I5, so 0. So those are 5 numbers. So I1, I2, I3, no I4, no I5. Alright, so now I'm going to write the third equation coming from here. So 0 I1 and 0 I2 and minus R3 for I3 and minus R4 for I4 and then R5 for I5, and those are the 5 values there. And then I move on to, this is my third equation, move on to fourth equation, which is first one here, I1 is 0, and for I2 the coefficient of I2 is nothing but 1, the coefficient of I3 is nothing but 1, and coefficient of I4 is nothing but -1, and coefficient of I5 is 0. So these are my from this equation, which is fourth equation, 1, 2, 3, 4, and then from the fifth equation I have I1. So the coefficient of I1 is 1, and coefficient of I2 is 0, and coefficient of I3 is -1. You can see the I3 is -1, and coefficient of I4 is 0, and coefficient of I5 is -1. So that completes my matrix here for A matrix. So and then I will also want to write B vector. So B would be your first equation on the right hand side is -b, and everything else is 0. So I'll have -b, and then you want to type is actually gonna go below, so because it's a vector, so 0. So what I will do actually, I'm gonna write semicolon and then put 0. So this is still vector, semicolon again, so 2, then 3, then 4, and then 5. So there are like 5 of them. So first one is -b. So now I have A and B created out of this by hand. So just remember that this is by hand. That was the first. Now I could write Ax equals to B. That was my main goal. So now I'm going to open up Matlab. So let's see, in Matlab, so I have too many files open here, but just ignore that. So and this is, I think, thing that I worked on before. So I will do I am gonna make this a little bit shorter so I can see that that matrix is there, so it will be clear, and CLC just to see there's nothing there in the workspace or in the command window. So then before I create my A matrix, you can see that R1, R2, those values are, you wanted to keep them as R1, R2 and V because you wanted to put those values separately. In your code, in your actual problem here, these R1 values are given. So these values you have to be a little bit careful here. R1 equals to 1, 5, 2, 10, and 5. They are actually kilo ohm. So 1 kilo ohm is 1000 ohms. So you have to assume that those are thousands. So 1 is actually meaning 1000. So that's how I will write. So so going back to Matlab now. So the very first thing you should do is write down all the R1, R2, all the resistors. So R1 is 1000, and then R2 is here, which is 5000. Then R3 is 2000. Then R4 is 10,000, and then R5 is 5000. So those are our values. And then I also wanted to write the V voltage given, which is 100 volt. V equals to 100. So so these are done. And then again, it would be a good idea if you kind of write all resistances given in ohms and voltage in volts. So it's just a note here. I think is kind of important. It's for documentation purpose, so anybody would understand what these values are. So now I'm going to form that A matrix. I'm going to open up that that Word document that I had before. So I am going to keep it here, and then I will easy to write my A matrix now. So A would be first 0, and then minus R2, and then I have 0, then I have negative R4, and then I have 0. So I'm going to put a semicolon. Then you can actually enter, so it kind of look like a matrix. So then I'm going to next line I'm going to write R1, and then I will have negative R2, and I will have R3, and I will have 0, and I will have 0. So I have second equation done. Third equation, which is right here, which is going to be 0 and 0, and then negative R3 and negative R4 and R5. So I have 3 equations done. And fourth equation, I have 0, and then 1, and then 1, and then negative 1, and then 0. So that's my fourth equation. My fifth equation is 1, 0, negative 1, 0, negative 1. So I have all the values for A is done, and now I'm going to write the B matrices. So B is given here, it's negative V, and then I can put a semicolon, and then 0, then semicolon 0, semicolon 0. So there are 4 of them, and one more, semicolon 0. Oops, I believe that's now right. 1, 2, 3, 4, 5. Okay, so all 5 of them. So now A and B is all created. So now this is what I mentioned, that this is what you have A and B. So first thing you should do after you set up A and B, first thing you should do, find the number of rows and columns in your matrices. So I want to call it lowercase r and lowercase c. That is rows and columns. So the way that you determine is size of A. Okay, so now we're going to say for unique solution, of course you have to have rows and columns are same. So if R equals C, that means rows and columns are same, which means number of equations is exactly same as number of unknowns. Now you wanted to check if determinant of A equals to 0. That means we know right away there is no unique solution possible. So you wanted to say printf no unique solution possible, maybe next line, and then you wanted to say printf again, showing reduced row echelon form. Next line, and I will later on copy and paste this for the other cases. So, and then you're gonna find our, say our maybe I don't know, our reduced row echelon form. So it's kind of going to be the same value. So let's do RR, reduced row echelon form. So RR equals to RREF, because I don't want to use the same function name with a different capital letter. I mean, it would still be this different, but sometimes it's hard to recognize what, you know, it's the same name is used. So then inside the RREF, there's a built-in function. So I'm gonna write A and the space B. So that's the augmented matrix. So then I wanted to print this guy AB, so RR. So I'm gonna have a printf and RREF, or you can say reduced row echelon form equals, and you can do next line, and then one more at printf. So here you are actually printing the values. So the printing the values, so the way that you want it to print is like exactly how it shows up right here. So, and in this case, whatever the first row is, you want it to print in the first row, so you have to convert that into columns, so it prints right away. So now the other issue is, like, you know, how many of the percentage sign you are going to be using. So that would depend on, because if there are like a number of columns, depends on number of columns, that many percentage sign that you are supposed to be writing. So what I would recommend for this case, maybe use a display command. So for this case it would be a lot easier to write. So display RR, so that way that's pretty much it done. But you can certainly write fprintf to print this, but then you have to have, like, you know, 4 or 5, or depending on how many unknowns there are, you have to create that many percentage this specifier to print the value. So instead, just display RR should take care of this. So then I will have else, so determine is not 0, then I will have unique solution. That is that you know for sure. So what I wanted to do is just, you know, copy and paste here. Unique solution, I would say exists, and delete this, and then instead of RR I'm going to write X equals to say A backslash B, A backslash B. So I have the solution. Then you can say solution equals and solution equals, and you can have this X printed directly using display command or a printf command. So you know, X, like, you know how many unknown is there, which is C. So you can use a printf. So because display is simply it's a lot easier, but let's see how to use a printf for the numbers. So I'm gonna say percent G, for example, and then I'm gonna do next line. So because depending on, I know the X is a vector, so it may have 3 numbers, 4 numbers, 5 numbers, all in the same column. So I wanted to print one number and then move on to the next line, or another number, move on to the next line, and keep going like that. So I wanted to print 1% G and then type in simply X, and that should take care of you know, all the printing, because you have the solution equals already written. So if you wanted to do one more thing here, that would be nice. which is like putting a tab. So every number is printed with the tab and the space in front, because in the first header you say solution equals, and then the numbers are going to be printed, a little bit a gap like an indentation there with the tab space and the space, which is 5 spaces, and then all the numbers are going to be printed. So that's this is the if else command is ending right there. So what I wanted to do, make it enlarged so you can see everything. So if r equals to c, then I have this. Then I wanted to write else if I wanted to say r greater than c. That means I have more equations than my unknowns. So then I'm gonna say if I have more equations than unknowns, then I'm gonna say printf more equations than unknowns. Printf showing reduced row echelon form. Next line. And then you do rr equals to rref, which is the same thing that we had before. So we'll have a and then augmented matrix b, and then I can simply copy this and paste it right here. So I'm going to put it right there. So that's else if r equals to r is greater than c, and then you can do else, which means r is less than c automatically. You don't have to show any reason here, because either first one was r equals c. You can see r equals c. This is r greater than c. The only thing left is r must be less than c. Then with slight change, I'm going to copy this whole thing, and then I'm going to say that less equations than unknowns, showing reduced row echelon form, and reduced row echelon form equals to this. So everything is covered, and now I'm going to say end. So this big if statement is ending right now. So there is a problem that whether you noticed or not, there is still there is a problem here. So the problem is like you found solution for 5 currents, right? So but there are 6 currents was solved. So you could write here the only 5 equations used to find 5 currents. We will use equation. You can show what equation we're referring to, and to show that I need to go to this original assignment. Let's say I6 equals to I1 plus I2. So you want to write I6 equals to I1 plus I2. We'll use this equation to find I6. So every time you have this, every time you have this, so you these are the 5 currents only, so you have to add one more column for the 6th current. So how do you know the 5 currents is like 5 unknowns, is coming from C? So I'll show you another way of writing this, so you can add that at the same time every time you have the solution. So there's a unique solution possible only in this one case. So I'm going to write x of c plus 1. So xc is 5 for that case. Now it is xx is going to be x of 1 plus x of 2, which is I1 plus I2. I believe that makes sense to you. So now this x should take care of all 6 currents. So and you don't need to worry about the other cases here, so because the 6th current is not visible here. So you would you can say that in this text somewhere that it's only 5 by 5 matrix is shown here, 6th current is not. Let's first run and then see what do we have. So I'm gonna hit run, right, as is, and we see that image solution exists, and then solution equals to, I have 1 2 3 4 5 6. There are 6 currents. So this is the space, tab space, that I was referring to. So for each time that there is something is printed, then there's a tab space and this space, which is total 5 spaces before. So this is your solution for that set. So I hope that makes sense to all of you, and one of you requested that I show a video for this. Hopefully this is already being a long video, so I probably should stop this.